At harvest time, no two fields are the same. Crop types, moisture content, field conditions, and weather all are important factors to consider when it comes time to get your crop out of the field. Jim Minahan has been following the harvest for over 15 years. He's a harvesting specialist with the customer service group at Case IH. Jim was there when the axial flow combine concept was developed and has been with it ever since. It is our intention in this VISTA program to have Jim share his expertise to help you learn more about setting and adjusting your axial flow to meet your ever-changing crop conditions.
Good morning. We're going to take a few moments and talk about corn harvesting. In the development of corn, the kernels can be hard or soft, big, round, flat, wet, dry. The cob can be dry or wet, easily split. When the corn gets to about 22-23% moisture, it begins to be easily thrashed. If it's higher moisture, it may mean a little more aggression in our threshing. At the same time, we need to be careful about the cob. As well as development of the ear, corn stalks can be small, can be wet, dry, can be large. All these have an effect on how we're going to thrash our grain. If it's dry, some of our earlier varieties shatter a little bit, so we want to talk about taking care of that problem. As well as we get into our adjustments, we're going to talk about the divider points, other adjustments in the corn head, the separator, cleaning system. Now to get started with our adjustments, let's go into the divider points. Since we're going to be making several adjustments to our corn head, and the header is going to be raised, we want to put our safety stand down, as it shows by this decal. One of the first adjustments that we want to make to our corn head is our divider points. We want to make sure that the center divider points all are on the same plane or same line or contact the ground simultaneously. The outer divider points, most generally we'll have those 1 to 2 inches higher than our center divider points. Why? Because the outer divider points will run closer to the adjoining rows. And to make those adjustments, go underneath the divider. We have a chain that we can move by the link and is retained with a rubber strap. Then to fine-tune the individual points, we have an adjusting bolt. Now that we have raised up our center divider points, we're going to talk about gatherer chain tension. The gatherer chain tension is maintained by a spring inside this spacer, linkage, and idler. If the gap between the washer and the spacer exceeds 1/8 of an inch to 1/4 of an inch, we need to adjust this nut down until we have freedom of the spacer or the washer just touches the spacer. Continuing, the stripper plates at some time or another may need to be adjusted. And one of these would be in the case if we had butt shelling of our ears. This will particularly happen when we have a dry, early variety of grain. And what happens is the ear is positioned against our stripper plate and knocks the kernels loose. And most likely then the kernels will fall down and out of the corn head, accounting for loss. To reduce this effect, we can adjust our stripper plates by loosening these two bolts and positioning a punch in a hole in the support that's adjacent to each bolt. We can take a hammer with the aid of some deep well sockets, which I use to get the right clearance front to rear. We want a closer gap in the front, wider in the back, anywhere from 1/8 to 1/4 of an inch difference. Once the sockets are in position, all we have to do is tap on our punch. Once we've got the stripper plate in position, we can go back and tighten up our bolts. This adjustment can be made from either side of the roll. Further adjustments in our corn head is the knife sections on the rolls. The normal gap is 1/32, but we can run up to 5/64 for a maximum gap. They are adjusted by loosening 3 cap screws from underneath and sliding the plates in or out as the gap would dictate. Now let's go underneath and see where these bolts are. Underneath our roll frame, we can see the stock roll knives. In there also is the 3 studs holding the knife in position, as well as the elongated hole which we can position the knife out or in depending on what our gap dictated when we check for adjustment. While we're down here, let's look at this standard weed knife, which is on the helical portion of the roll. This is standard. If we are in a heavily infested field with grass and our rolls are wrapping, we can purchase this field attachment. Weed knife is about 10 inches long, extends on up the roll. Now that we've looked at our roll frame from underneath, let's go back and see what protects the rolls and our gathering chains, which is the slip clutch. Each of our roll units in our corn head is protected by a slip clutch. The slip clutch protects the knife rolls and the gathering chains. The outer case of our slip clutch is what actually drives the roll unit. Through the slip clutch is a shaft connecting to the remaining gear cases. If a particular slip clutch should slip, this will not affect the driving effort of the adjoining gear cases. The slip clutch torque can be checked at the outer end of the main drive shaft. To check our slip clutch torque, we have removed the chain, and by taking this sprocket off, we can use an 1 1/8" socket to fit this shaft. And with a torque wrench that can measure 250 foot-pounds, we can attach it to the end of the shaft. And with the aid of a piece of hardwood stuck in a roll unit between the knives, restricting them from moving, we should be able to rotate this shaft, checking its slippage. The slip clutch again is set at 250 foot-pounds at the factory. If we should have to overhaul it for whatever reason, and we put it back together, this would be the method in which you would check it once the spring tension is set. Now with the wrench, we can see or hear and feel the jaws slip past in the slip clutch assembly. To get a better view of what we have just looked at, what is happening is the ratcheting of these jaws is what you heard. The tension on these jaws is controlled by this spring, which is under compression, and to measure its compression we use this surface of the plate 1 3/4 inches to the top of this washer. The corn head cross auger is adjustable up and down by loosening these 4 bolts so that this support plate can be moved on the left and right hand ends. Also, with the aid of slots, we can go fore or aft with our auger. When would we adjust this? We would adjust the auger up for food corns, for example, and down if we got into some green, damp conditions where the material doesn't want to feed into the feeder house. Next, let's go into the drive sprockets, which control the speed of our rolls and our auger. Coming from the factory, the drive sprocket is 35 tooth and drives our rolls at 1120 RPM. We have an option sprocket, 30 tooth, driving the rolls at about 950 RPM. Further, we can slow it down with the aid of a 26 tooth sprocket, driving the rolls at approximately 825 RPM. When would we use these slower speeds? These slower speeds would be used in a crop condition if we had wind damage or bug damage and the crop was laying on the ground and the stalks are gathered rather quickly. This has a tendency to snap the ears. As well as when we get into some food corns, since they're early varieties, we have a butt shelling problem, we can slow the rolls down there also. Continuing on, as we get into down corn conditions, and can be seen by this wear pattern, stalks have a tendency to wrap in this general area. Now if it's standing good like this field of corn is here, we have nothing to worry about. But in those wind conditions or bug conditions where the corn has gone flat on the ground, we can take this part of our ear saver off so that the stalks that are gathered by our outer dividers can slide right up and let the gatherer chains and our rolls have a chance to pull this stalk down through our roll unit. And now, let's go on over and look at our header level. Corn head level. It may not be as important as with a rigid header for grain or a flex header for beans, but still we want all the row units to be on the same plane as we're going through the field, such that in down conditions we want the gathering chains to gather in all the down ears of corn. And to do this, we loosen these 4 bolts, and by taking this adjusting bolt and pushing it forward through this bracket, we will raise the left end. By taking the same bolt and pushing it to the rear, we will raise the right end. As a quick and ready reference, if we're unable to get to a hard flat surface, we can use the separator frame as well as this back sheet to see if our header is parallel with the separator. And now, as long as we're on the feeder house, let's go over and look at our feeder chain adjustment. Feeder chain adjustment should be monitored frequently, especially when you're using larger combines and larger corn heads. To adjust our feeder chain, we have 2 adjusting bolts, one on the left, one on the right. By loosening this pivot point, we can pull the bolt forward, which will tension the chain, or relax the bolt, taking the tension off. What we're watching for is the clearance of our feeder chain slat off the bottom of the feeder house. The clearance should be 1/32 to 1/8 of an inch. Also with corn head operation, our header drive belt tension should be maintained daily. That is controlled by this spacer in which there's a spring inside, and the tension on this spring should be such that there is just clearance between the spacer and the washer. A frequently used attachment with our larger corn heads as well as headers is our nitrogen-filled accumulator. What is the accumulator? The accumulator is an attachment that can be exposed to the hydraulic system to act as a shock absorber for rough ground and so forth. To properly set the accumulator, we must have the header all the way down and at rest. We open this valve, allowing the gas to force out all the oil back into the hydraulic system. Then we'll close the valve. Then we'll start our combine up and raise the header up about halfway. making note on our ruler as to what this might be at this particular point. Then we'll go back, open our needle valve. The header should settle from between 6 to 10 inches. Checking to see if this has happened. If it only settled 1 to 2 inches, we then need to relieve some gas pressure that's in here by removing this cap, exposing the Schrader valve, and releasing some gas pressure. As we see the header settle, go back and remeasure. We get into this 6 to 10 inch range. Repeat this several times so it becomes consistent. Once it is consistent, put your caps back on the valve. Now that we have reviewed our adjustments on our corn head and feeder housing, we're going to go back into the separator area of our combine. But before we get there, let's stop and understand what rotary threshing and separating is. In the case of our axial flow combine, once the grain leaves the feeder chain and goes towards the concave, it will go front to rear approximately 24 inches. A little bit different than a conventional machine, where it went from the feeder chain immediately into our cylinder. But in the case of the rotary threshing, particularly our axial flow combine, here's where the difference starts to come in. Not only did we go front to rear 24 inches, but on the 1680, for example, the grain will travel 6 feet from the time it leaves the feeder chain until it gets to the first concave. How is this accomplished? Between the feeder chain and the first concave is a transition cone. This is in the shape of a funnel. Within the cone we have some directional vanes. Also we have some impeller blades. These impeller blades are attached to the rotor. The impeller blades draw the material away from the feeder chain with the aid of the directional vanes, meter it out, accelerating it, getting it ready to be thrashed on top of the concaves. There's where our rotary threshing and separation begins, and also the whole kernel concept of our grains. And now that we've gone through our header adjustment, feeder house adjustments, let's go into the separator and see what makes this combine work. With our grain having traveled through our transition cone, it's going to go into the concave area, but before it will travel up this little skirt, getting on to concave number 1, and also concave number 2 and 3. As can be seen here, this is our large wire configuration, standard in corn. Can also be used in soybeans. In this area of the separator housing, we have directional vanes, and they're tied together in pairs with these plates. There are 3 sets of plates. The vanes normally come in the middle position, which is for standard conditions. If we get into a hard threshing condition with our corn, we can move the vanes to the rear. What this will do, it will add into the travel of our material as it's going through the concave area, helping us thrash in tough conditions, such as a wet corn condition or a cob problem. Also, if we get into a real easy threshing corn, we could pull the vanes to the forward position, speeding up our flow of material, as well as our threshing and separation. Also in this area of our concave, we can remove straight rasp bars from the rotor in rows number 1 and rows number 2. What this does is allows the material to be speeded up in its flow through the concave area. This can be done particularly for edible corns as well as soybeans. And now for a better look, let's go out here and look at our concaves and see what their construction looks like. Shown here are 2 concave types. The first one is a small wire, is standard in wheat, small seeds, grasses, and so forth. Being it's the number 1, we have a skirt that's welded to it. This skirt helps to get the grain from the transition cone out onto the first concave. Second concave is a large wire configuration. Large wires, large spacings. standard for corn, rice, milo, and other seed crops, which are large. Also, this large wire concave, we can pull every other wire out for use in edible crops, such as lima beans and so forth. Or, in the case of fruit corn, sometimes we want our whole kernel quality concept. We then, too, will pull every other wire. Now, let's go on back into the separator housing and look at our separator grates. In the separator grate area is where we do the final separation of our grain. Within this area we have 3 separator grates, 1, 2, and 3. Installed in this machine already is a keystock grate, which is standard for corn, soybeans, rice, milo, or any other tough green condition. Also, we have directional vanes in our separator housing, of which there are 5. Different than on the concave, these vanes can be moved individually. But as we see here, we've moved them as a complete set. Also, we have positioned them in the slow position for corn because this gives us sufficient time to get rid of all of our kernels before the straw, cobs, and shucks go out the back of the machine. Also, if we're in a condition where there is a lot of green weeds, the crop is green and tough, say in milo for example, we can take the separator bars off of the rotor, which are located on the rotor, and install notched bars. What do these do? These make the material very active in this area, cutting down on our rotor loss, if we should have any, and moving the material rather readily through the separator cage and out the back of the machine. And now, to get a closer look at our separator grates, let's go over here. A closer view of our grates, we see we have 3 different types. The first one is our keystock grate, which is standard for corn, soybeans, milo, or rice, or any other crop that needs some extra separation when there is a green stemmy crop involved. Our second grate is our punch grate. We have bars over the holes for small grain harvest, such as wheat or our cereal crops. They also can be placed between the holes when not in use, thereby opening up the slots more. Or if we elect, we can also put them in a toolbox. If we need a little fluffing in the lighter crops and do not have keystock grates, we can take the bars and put them between the holes on the inside, fluffing the crop, adding to our separation. The third grate is a solid grate, primarily used in sunflowers or any other crop where the stem breaks up, but we've also had completion of our separation and we want to restrict the material from going down onto our cleaning system. We can put these solid grates in, thereby moving the material out of the separator area and not congesting our cleaning system. Now that we've looked at our grates, let's go into the cleaning system and look at the different sieves that we have available for our corn combines. Shown here are our 3 chaffer sieves. They are located in the separator housing along this plane and are used in connection with our cleaning fan. What is a chaffer sieve? Really, it's kind of like an air valve. It controls the air pressure from our cleaning fan such that it will blow the light chaff out the back of the machine, as well as changing the dimension of the grids. We can walk out the large particles of straw, corn cobs, and so forth, as well as the construction will let the large seeds fall down through. The vanes are constructed in the 3 sieves here differently. This is our standard corn slat sieve, 1 5/8" spacing, and has a very deep finger. Our second sieve is an 1 1/8" spacing, shallower finger, standard for grain. A third chaffer sieve is an option, 1 5/8", shallow finger, mainly for green milo and other crops that are on the green and tough order. To get a better view of our vane construction and finger spacing, we have these fingers. This is a corn slat with deep fingers, and it is constructed at 1 5/8 spacing. Our second vane is a shallower finger. It is also standard for our grain machines at an 1 1/8 spacing, or as the option sieve, 1 5/8. Further into our cleaning system, let's go look at the shoe sieves. Our shoe sieves are located in the separator housing between these two pivot points. What is a shoe sieve? A shoe sieve is one of the final steps in cleaning of our grain in the separator housing. They let the grain go through, as well as float out unthrashed heads, so they go back into a tailings elevator and be rethrashed. Looking at our examples here, the first one is our standard 1 1/8 spacing shoe sieve, general purpose, used in most of our harvesting. For those that want extra high capacity, we have a shoe sieve option, 1 5/8 spacing, closed slat design, especially for corn or large seed crops where we desire high capacity. For a closer look at our vanes, we have the standard vane shown here on top with a very shallow finger at an 1 1/8 spacing. Our second vane is a closed slat design at 1 5/8 spacing. And for a quick review, going back to our standard shoe sieve, when we measure spacing between our vanes, it's measured from tip to tip or wire to wire, whichever the case may be. Now that we've reviewed our cleaning system, let's go look at some grain samples. Shown here are 3 grain samples, one of which indicates we had an over threshing problem. Could be caused by the concave being too tight or the rotor running too fast, indicated by the small pieces of cracked kernels as well as some whole kernels that are nicked. Not only will the concave and rotor cause problems with cracking a grain, a loose elevator chain can cause a crack that looks something like this. Our second sample shows cob particles a little bit bigger, indicating that we still may have an over-threshing condition because of a soft cob. We may want to open our concave just a little bit. The sample does not show too many cracked kernels, indicating our rotor speed may be about right. We could remove these larger pieces of cob more than likely by closing up the shoe sieve. Our third sample of grain free of cob, relatively few cracks, if any. A sample that we'd like to take to the elevator or put in our storage bin. Since we've reviewed the corn head settings, adjustments, feeder house, our separator and cleaning system, the next thing we ought to do is look at the operator's manual to see how we would set our machine for corn. On this particular page, we have all the machine settings for various crops. Since we're going into corn, we would follow along this line, setting up our machine. These adjustments, or measurements, or speeds, are to get the machine started in the field. They're normal settings. As the conditions in the field dictate, these settings or adjustments may be changed or have to be changed. Once a machine has been adjusted for field conditions, the next item is to go into a kill stop to further identify the machine settings for the conditions that the machine may be running in. And to do this, we will use the brakes to attempt to stop the machine as quickly as possible, simultaneously taking the SR lever, pushing it all the way forward. Third, taking the throttle and pulling it to low idle. All this will help to stop the machine as quickly as possible in a loaded state, such that we can go in once the separator is stopped and look at what's happening on the concaves, grates, and cleaning system. An important thing to do, the moment the engine is stopped, is to restart it, because there's going to be heat in the engine and we need to get rid of it and get it to a normal cool down state before we shut it off. Also, there's going to be dust in the machine anyway, so you might as well sit in the cab, wait for the dust to settle while the engine's cooling, and then shut the engine off. Now that we've completed our kill stop and removed our excess panels from the separator housing, we can look at concave number 1. It has some loose kernels in it. And continuing back into number 2, we see a few less kernels, indicating separation is beginning to occur. As we get into number 3, we see again a progression of less kernels. By the time we get back into the first grate, there is just a few kernels still left in our straw or wanting to be separated. By tickling our belly a little bit, looking for some loose kernels in number 2 and in number 3. Hopefully we find none and that our separation is completed. One other thing we can look at while we're in the separator grate area is the texture of the mat. We don't want it so dense that if there is a kernel in that mat, it still needs to be separated. With the mat being rather loose as it is here, this kernel can still work its way through and be separated before we discharge the cobs and shucks. Also, we notice the texture of cobs in this area. And what we're looking for is the whole cobs that can come out of a rotary combine. And now that we've looked at the action on the concaves and separator grates, let's go back and look on the cleaning system and discharge chute and see what the texture material is there. Coming back into the sieve and discharge beater area, we can get up on top of the discharge pan and look and see if we may find some kernels. Hopefully we find none. Also, down onto the chaffer sieve, we can see how the chaff mat is laying. We may also want to pat it. That sound is kernels falling through the chaff down onto the shoe sieve. As you see this chaff mat here, this is basically as it was when the machine stopped. It simply settled, carrying the grain, cobs, and lighter chaff particles with it, and it is resting on top of the vanes. The large pieces of shuck you see here and some cobs are what fell off of this discharge pan as the machine stopped. Also up here, we can look down through the chaffer sieve and look and see what the load may be down on our shoe sieve, and will give us an indication what we may see in our tailings elevator lower boot door. Now that we've completed our inspection in here, let's go look at the tailings elevator door. After having looked at our chaff load on our chaffer sieve and for any grain loss on the discharge chute, the next thing we want to do is look in our lower elevator door to see what kind of sample or material is coming off the back of the shoe sieve. As we look at this, we do see some finer pieces of the cob, lighter chaff that the fan is blowing out, some bug damage, some immature seeds which are light. What we're looking for also is any part of the cob that may have a kernel on it. If we see too many pieces of cob with kernel on it, it may be an indication we have a soft cob. We may have to slow our rotor speed a little bit and open up the concave and go through our rotary separation to get these kernels that may be on these pieces of cob. Also, in this sample, we don't want to see too many whole kernels. If we see too many whole kernels, they're going to go back into the concave and likely to get cracked again, losing on our whole kernel quality. This sample looks pretty good. A lot of light fines. not too many pieces of broken cob, and our auger is running about 1/4 to 1/2 full. Now that we've looked throughout the machine, as we made our kill stop, a box was placed under the separator and the machine drove over it to see what our losses will be from the cleaning system and the rotor. Looking at our loss check box, which is 1 foot front to rear inside, as well as 4 feet in length to cover the width of the separator. In the box, check our cobs that fell in there for any loose kernels that may be in the chaff. Looking at the remaining pieces of cob, lighter pieces of tailings, immature kernels. This particular sample, there are no whole kernels in the box. Also, while we're looking in this particular box, we can check and see if we see lots of cracks. Lots of cracks means over threshing. Also, if we had our shoe sieve too tight, too many tailings are going back into our concave and being thrashed, these pieces of the chips off of our kernels could land back here because of the fan. This sample here looks pretty good. Now that we've looked at the losses coming from our cleaning system and the rotor, let's go up into the header and see what losses may be up there. In making our corn head loss check, our check needs to be at least 10 feet behind the standing corn. This will allow the gatherer chain, stock rolls, and auger trough to have passed over this area, and we can collect any loss that may have occurred. With the aid of the box, you can measure off 4 square feet. This is going to be different up here in that the kernels that we pick up here will be the spread over 1 acre. And to check for that, we can refer to our operator's manual. Our corn loss table for the 1083 corn head 30-inch row is 1.84 kernels per square foot spread evenly over 1 acre. But we've collected our loss from 4 square feet, so we have to divide by 4 to know what our loss per acre is from our corn head. Marking off our roll, we happen to be in the center 2 rows of the machine, which is also representative of our separator. Moving the shucks. One thing you got to be careful here is your loss is going to be in the row. So when you pick up your shucks from out of the row, you need to be careful that you don't take any of your loose kernels with you. One kernel. Sometimes with our earlier varieties of corn, you'll see a lot of customers pick up the shuck. They look down inside. And what they're looking for is shell corn that can be down here at the butt, caused by the corn head when it plucked off the ear. This particular example, no loss. Also, our rolls may be too fast for these dry early varieties of corn, and our butt shelling would be occurring at the rolls, and we may see it laying in where our stubble is. These would be things that we'd be wanting to watch for when we were checking corn head loss. Now that we have looked at our header loss, let's go out into the cornfield and see if there's any loss out there of loose ears, because once in a while we can have an ear loss from our corn head. Going out into the standing corn, we need to be looking for loose ears caused from wind or bug damage. Also, while we're out here, you can go into the first and second row and look down on the ground and look for any loose kernels that may be out here thrown by our straw spreaders. This is a good place to check for rotor loss. The important point on the 1000 series headers that's overlooked frequently is that when we go to put a 1000 series header on an 80 series combine, or for example our 1680, we should take these side deflectors on either side and move them out one bowl hole. Because if we don't, and we leave it in the shipping position, which is for the 1640s, 1660s, we create about a 6-inch grain leak on either side of the feeder housing, and that grain goes right out onto the ground. With the inspection of our grain loss that may have occurred in the standing corn header out the back of the separator, we've also looked inside of our machine after a kill stop. As evident can be seen here with our corn head, the machine after a kill stop is full of corn. We want to save that corn, and we do not want to dump it out in the ground as we start the machine up. So the procedure to start after a kill stop is, as the engine is started, position the throttle about halfway. Then flip the separator switch, and as the load begins to pick up, increase the throttle up to near high idle, and as the rotor starts to settle down, pull back to somewhere just above low idle. This will allow any of the grain that's trapped inside the machine to go up into our grain tank. Now that we've discussed how to restart our machine, let's go up in the cab and look at our grain loss monitor. The grain loss monitor is mounted in the upper right hand front corner of the cab. There are 3 control knobs. The first one being grain selector. What this is for is governing the size of seeds that we're going to be harvesting, and such we're going corn here will be at the larger dot. Second control knob is for sensitivity of our pads. Also, we can set this control knob to what we see for losses behind the combine, on the ground, or in our checkbox. Our sensor switch. From the off position we go to the chaffer, of which there are 2 pads, left and right rear corners of the sieve. Next, we go to the rotor circuit, of which there are 2 pads, left and right, at the rear of the separator cage. To monitor both circuits, we go to both. Also, while we're going through the field, this light bar has 4 lights in it, which will flash intermittently as cob, chaff, or grain strikes them. So they'll be flashing as we go through the field. On the bottom is a meter. This meter can be set with our sensitivity knob such that the needle can be in the middle or at the beginning of the green. One thing to be watching as we go through the field, and I'll demonstrate, as we speed up from a preset throughput, the needle will drop back. As we slow down, the needle will go up. This is a time and distance machine, and for the electronics to catch up with the motion of the machine, the needle will respond by dropping down as we speed up and will move up as we slow down. Each time we turn the ignition switch on, the grain loss monitor goes through a self-test. The light bar will light up, as well as the meter will go over to max and come back to 0. Meter's coming back. It has completed its self-test. Anytime we should turn the ignition switch on, this will repeat itself. As well as if the ignition switch was turned on and we had our sensitivity switch off and switched to chaffer, rotor, or both circuits, this will also go through a self-test. As we go through the field, you may be able to view these lights flashing on and off as an indication of material hitting them. As well, as we get our ground speed up, we'll adjust the bar such that the needle will rest in the center of the green or at the beginning of the green, depending on the customer's preference. As we bring the machine up to a normal throughput setting, we're going to take and set the grain sensitivity knob so that the needle is in the middle of the green. Now as I increase my ground speed, the needle is going to go to the lower portion of the green quadrant. As I decrease my ground speed, the needle is going to go higher in the scale. The reason for this is time and distance, and the electronics has to catch up with the normal ground speed. Now as we increase our throughput back to the normal setting, the needle should come back to the middle of the green quadrant. Now that we've gone through our corn head, separator, cleaning system, our grain loss monitor, let's go cut some corn.